Hello friends, how you guys are doing? Well, I decided to make one complete playlist on the core Python because unless and until you have a good concept or good grasp over the core Python, a framework like Django would be a little bit different and you will not enjoy. So in my playlist, I'm going to provide like from day 1 to day 12. I've thought that these number of days and the module which I will be covering up is sufficient enough to start with. But yes, of course, as you do more, your knowledge expand. But this is like a warm up. You can start after this 12 classes, you can get into Django. Okay. So today is day 1. Let me expand the day 1 folder, and as I do that, you will find the day 1 consists of 4 different parts, starting from variable, list, tuple, and iterator. As we move on, we'll come across the other modules. So right now on the right hand side, you can see over here I am logged into the day 1 and we'll get into the folder called part1. So cd part1, and we are inside the variable. Great. Let me clear the screen. So what are we going to do? We're going to let me expand the part1 folder, and here you have got a couple of more files. So I will write Python, and the file which I will execute is without function. Yes, the first program is going to be without function. I will not hit the enter because as I do that, the program will get executed. Let's open the file, and here we go. You might be seeing a lot of statement over here, but I will explain them one by one. Don't worry. So the first 4 line, what we have done, we have created 4 different variables of different data types. Although if you see over here, I have mentioned the data type, but Python comes with a feature called type inference. I repeat, this is a very smart feature of modern days programming language that is called type inference. What does this mean? It means that if you just declare a variable without mentioning the data type, then it also can identify it based on the data that you're providing. But if you really want to go for mentioning the data type explicitly, welcome to do so, like what I did. In that case, you have to write the colon followed by the data type and then the assignment operator, and you're assigning the value. Okay, so this is a way of like declaring a variable of a particular data type and assigning a value of that type. So over here we have come across 4 different primitive data types like str, int, float, and boolean. So these variables are all been initialized right straightforward. Now we are going to use something called print. So what print is going to do? What is print all about? As we know that, in case if you have done C language, you will be knowing, or any other programming language, you will be knowing that anything that has got parentheses and before that there is a word, then the parentheses involved, it means it's a function. So print is a function which is responsible for printing the values, right? But if you note over here, you will find very interesting. So if say print is a function and these are something that is going to print, that means how many, what are these actually called? In what way you can call this? Well, these are actually the parameters, right? The print function has got following parameters. So I can say the first parameter of print function is a string, and the second one is a memory reference. Can I say that? Yes. Now if you come over here, this reference is of type int, this reference is of type float, this reference is of type bool. So I can say that the print function can take or accept the parameter which can be of different data types. Well, if print is a function, then naturally you might be wondering, are we going to do a function? Yes, of course. I will be rewriting this piece of code making use of function as well. So that would be a custom function, but these are all system defined functions. So functions can be classified as a user defined or system defined. Okay, so these are system defined functions. So here I have declared the variables, here I have printed, declare as well as assign. What about this? Well, these are all constants. Like what the speciality of constant? Well, when you declare variable all with uppercase, by convention it is called constant. But remember one thing, by default in Python we don't have any such hard code constant concept. This is just a way of practicing. Okay, it's a convention, you can say so, that if you want to declare anything that is constant whose value you don't want to change, you have to write that with the uppercase. All the letter has to be in uppercase, so that would symbolize to the end developers that these are constants. Okay, so variables with all lowercase are regular variables, and variables with uppercase will denote these are constants. And here we have given the constant value, like the constant value of pi, and the value of, here I mentioned the range of the integer value. So this is the range starting from the positive, it will go up to negative. Okay, so this is a range value. We cannot give anything beyond this, and if it is of type integer, this range should be my input should be within this particular range. It should not exceed this range, or it should not get below this range. Okay, so that's what is going to be print right over here. Okay, fine, and let's look up some of the operators. Here we are going with two variables, and then we perform some basic operations by assigning, like mathematical operation we are simply doing it, and we are assigning it to the respective variables right over here. The same goes we are printing over here. And the last part is something that is different, because this is the place where I'm showing you how to take input from the user. Well, we'll get to this particular piece of code. Let me run the code so far what we have understood. I hit the enter over here, and as I do that, the output would come right in front of you. As you can see, the variables, all variables got printed over here. The constant also got printed over here, and the for operation which we did got printed right over here. So far so good, isn't it? Now we are left with the last part, and that is enter your name. Here I'm supposed to enter my name. So input is a function that would take input from the user. So far so good. Let me write my name, Swaroop space Kumar space Saha. As I hit the enter, what will happen? Well, it would store the data inside this particular variable. Again, I have mentioned the data type str over here because I'm taking a string input. That's the reason I did that. Okay, again I'm telling you, Python support type inference. You might skip the data type, but since you are starting from the very beginning, so it's a good practice to write the data type as well. As I hit the enter, again it is asking me to enter my age. Okay, that's nice, but my age would be of type string. Is it of a type string? Of course not, it is a type int. But by default, when you're writing input function, whatever input you're going to take, that would be of default string type. But the same input function I'm going to use for taking integer value. In that case, what you have to do is that the concept called typecasting comes in picture. You will be using the same input function for taking both string as well as integer or float or boolean whatsoever, but you have to typecast it to respective data type before assigning it to that particular data type variable. Like age, I have declared it as type integer, so make sure I will typecast the value, and thereafter I will assign it inside the variable age. Okay, that's really nice. My age is 89 years. So far, very so sweet. And the value got stored over here, and I can see the output. That's all from this particular program, not from this video. Okay, so we learned over here how to handle or how to work with different variables, assigning different data types, and we also learned a glimpse that we can take input, and this input can be of different types. But all these things we did without function. Rather, I can say that I was using system defined function in the form of print and input, right? So these are system defined functions. So shouldn't I learn how to write my own function? Of course, that would be my next file. So let me open my next file, and here it comes. This is the file where I have gone for user input through the functions. Okay, let me clear the screen so that I can run the program separately, and this time I'm going to work on with underscore function. So I will write again program Python, and my file name is called with and underscore and its function. Okay, so as we can see right over here is that I'm showing you how to pass a parameter at the same time making use of function. So I have a function called print underscore name, and it has got one argument. Oh, that's great. So this argument is of type str. Again, I'm telling you, by default you can skip the data type, but still it's the first time, so you should be acquainted with these things. So the name is a variable which is of type string, and this name is written within the function, so it is called an argument. So this data should come right over here, and here is where the function is getting called. So print underscore name is been called, so the control will directly jump from here and will assign the value alice to the variable name, and that would get printed right over here. That's really nice. Okay, so that would be the first part of the function. Similarly, I can write another function where I can pass an integer as argument. So here I pass string, here I pass integer. So this value I will be coming from this particular function call. So over here I'm calling the value 25. That 25 will get stored inside the variable age, and finally it's going to print the value which I have given. That's how I'm writing a function that takes an integer as an argument. And I can also write a function that takes float as an argument. So I'm showing you over here different functions that is taking individual parameters which is based on different data type, or I can say individual arguments which are of different data types, right? So here also I'm passing 5.6, and that value will be taken inside the height, and eventually it will be displayed over here. Now you might be wondering that I have been using 3 different functions with 3 different data types. Can't we also use boolean? Of course we can. So here is also a boolean comes in picture. So when you're talking about boolean, the data will be in the form of true or false. Remember, when you're writing boolean, the first letter should be in uppercase. So here I wrote true, so T is in uppercase. Similarly, if I write false, the F would be in uppercase. So that true would come and gets to inside this particular variable, and then I will do a checking. Okay, this is something unique. Here I'm introducing with something called decision making. So here I don't need to decide anything, I just wanted to print the value, but over here I want to take a decision, because you don't know whether you are a student or you're not a student. If you talk about me, I am always student. So over here is student is going to be true, right? I pass the value true over here, and I'm checking is student true? Yes. If it is true, then it will print the value I am a student. If I pass over here false, then you will check if is student is true. No, it's not a student, so it's a false, so it will not execute the if part, it will come to the else part, and the statement I am not a student is going to be printed, right? So that's how the decision making statement is applicable when you are passing an argument which is of type boolean. Really sweet. But man, you have been showing the functions with only one argument. How about multiple argument? That also can be achievable. So over here we have got a series of arguments. So str for name, int for age, float for height, and bool is student or not. The same thing what I did above, I just wrote it once again, and here also I perform decision making, and subsequently I have to call this function, right? I have to call this function. Now while I'm calling this function, you need to be very careful that you are passing the right data, what we have mentioned over here. So this first one is string, so Alice goes over here. The second one is age, 25 comes over here. The third one is float, 5.6 comes over here, and true comes right over here. So that's how these these are arguments. That's how the arguments are been initialized, and finally they are just been printed over here. Okay, so let me run the code, and I believe you can follow what it is been done. So my name is Alice, that comes the first function. I am 25 years old, that comes from second function. My height is 5.6, that comes from the third function. And I'm a student. Of course I'm a student. For the last day of my life I will be student. So that's about the fourth function. And finally we're in the last function, which has got multiple arguments. As you can see over here, all the arguments got printed one by one, and the decision making has been taken as the last part. That also got printed over here. So you saw that how you can write a program using function. Before I go to part 2, I just put forward one question. Okay, you will tell me I don't know the answer of this question, I just know the question itself. If you notice one thing, I have defined the function at the beginning and I've called the function at the end. Can I flip the process? What I mean is, can I call the function at the beginning and I define the body of the function at the end? Will it work? I don't know. You check it out and you drop a message in the comment section what's going to happen in that case. That's a beautiful question. Please take a note of this question. Okay, so with that we come to the end of my part 1 of day 1, and now we move to part 2, which is the list. All that we are going to do over here is a very fundamental. Nothing like I'm showing you at the granular level. Nothing smaller can be. Nothing like just if you cover up this portion, you are good to start with. Okay. So I was inside the part 1. I need to step out of part 1 now, and I'm going to get to part 2. So part 2 is what I have to get into. Oh, sorry, my mistake. I have to write part 2, and then I have to write list, because that's the folder name. And now inside this, let me clear the screen, and now I have got 2 program over here, list underscore hetero, list underscore homo. Let me open the list underscore homo. As I do that, here is the file. Okay, very nicely written. So let me write the execution. Python, the one I will be showing is list and underscore homo, and I can hit the enter. But before that, let's go and check it out. What do you see over here? Let's look at the comment section. Whenever you are doing a program, make sure you write the comment section. This is very handy, not for you but for others who are going to see your program later on, because you might not be working in that particular project in future, but there will be other developers who would come and work on that project. So for that reason, it is a very good practice that you provide the comment statement, and these comment statements should be flexible enough to understand that what exactly you are doing in that piece of code. Okay, so that's the way you learn, and that's the way you teach for others. So over here, as you can see, I said that this is for the homo. That means every data is going to be of same data type. So I've created a list, and I'm very sure when you will look at this line, you might be thinking about your C array. Yeah, somewhat you can say so, but of course there is some difference, of course, but the representation is very much like an array. So third bracket is over here, and I have got the following items: 1 2 3 4 and 5. So my list is going to print all those items, right? Okay, let me do that right over here. As I hit the enter, you will see the execution of the entire program, but I will explain one by one. Okay, so I created one list, and now I'm going to print the list, and that is the reason why you are seeing this particular list. So whatever input you have taken, oh, I didn't take any input, I gave the hard-coded value. Fine, you can take the input as well, that also you can try out, no problem. So I have created one list, and I just printed the list, and it came as it is. List comes up with some system defined functions which are very important for the interview purpose, and they will be asking you this question, so be sure about these things. The list has got a function called append. So I'm going to append 6. The word append means something like I'm appending or modifying, right? If you talk in day-to-day life, if you say what is append, like you may think it like I'm modifying something, I'm changing something, right? But over here you're not modifying. Actually what you're doing is that you're inserting an item at the end of the list. Please follow my line. You are not modifying, or you can say that yes, I'm modifying the list but not any item within the list. I'm keeping those items untouched. Well, I am modifying the list by inserting a new item at the end of the list. Okay, so whenever you give a call to append, remember it would add a new item at the end of the list. So for that reason, if I print the list after appending, you see the value 6 right at the end of the list. So the insertion at the end has been successful. I know now you will be thinking, can't I insert a new number in between the list? Of course you can, and that brings us to a new function called insert. So when you're inserting an item, you have to mention two things: the position where you would like to add, and the new item that you would like to insert. So when I'm saying 2 means what? The 1 is at 0 index, 2 is at 1 index, and thereafter the item will be added. See, the item got added. So after 1, so 0 and 1. So when you're writing 2, you are thinking that this is the first one and the second one. That's what you were thinking. But behind the scene, we all know that indexing starts from 0. Although I didn't show you anything, but by the time I will come over here, it will be very clear to you. So this is the 0 index, this is the 1 index, and thereafter you are inserting the new item. Okay, so remember always indexing starts from 0, and that's how the insertion takes place. So over here you are inserting. Many times this question comes in interview, is that when you're inserting at a particular place or a particular index, there exists one number. What will happen to the number? Will that number get overwritten? The answer is no. It will just shift, like what you saw. 3 is not replaced by 7, but 3 got shifted, and at that place 7 got inserted. So that's how the beauty of insert function is working. So remember, append will take one argument and insert will take a couple of arguments. The first one is the position indexing, and the second one is the item that to be inserted. Now if you want, you can perform another function call that is called remove. So I remove 7, and that's the reason why in this particular printout you don't see 7 anymore. So make sure before you remove, the item has to be there. Now what if the item is not there? Well, that part I didn't cover up, but definitely in the upcoming days I will be covering more details in context to the topic that I'm explaining right now. So there where we'll take care about this particular situation. But for the time being, consider the item is there in the list, and thereafter I removed and I printed it back. I see that the 7 is no longer there. Okay, very good. And we come with a function called sort. Although the list is already sorted, had there been unsorted, then the thing would have been different. Suppose I would say that, suppose instead of writing a 3, I'm saying it's 9. And now let's rerun the code, and if I do that, you will see now the sorting takes place. See over here. Here until now there was no sorting taking place, but after that you sorted and you got the new sorted list, right? So that was the context of sort. Similarly, you have a reverse. So when you're printing the reverse, of course, from the back, the reverse order will be taking place, and as you can see right over here, the reversing took place. Now, here you must take up particular. You need to be very careful about this. Now, when you are performing a reverse function, actually the list is getting reversed. So that means the whole indexing will start from 0, but the value of this would not be what you were seeing previously. So that's the reason when I printed the index position 0, I got the value 9, because you did the reverse. And actually when you did the reverse had an impact on your list. So that is really very important. Okay, so remember, it's not just to show you the reverse order, but actually the list got reversed, and for that reason when you do indexing, you would be seeing the previous value, not the I mean to say that you would be seeing not the value at the 0 position which was previously, rather you are seeing the new value that came after reverse. So for that reason 9 got printed at 0 indexing, 1 got printed at at 1 in index number 1, the value 6 is there, that got printed. Okay, so that's how the indexing is actually working. So you saw one thing, that when we are indexing, the indexing starts with 0. Okay, and then we move on to 1, and then to 2, then to 3. In this way it goes on, right? But what if, and this is all in positive format, but what if I go for a negative indexing? Well, in that case it would be from the backtracking. Like over here, when the initial array was like this, 1 2 3 4, the indexing was like 0. At 0 index you had a value 1, at 1 index you have value 2, at 2 index you have value 3, at 3 index you have a value 4. That's how the indexing was going, if it is a positive index. But what will happen when I go for a negative index? Look, well, when you're going for negative indexing, it would be starting with -1. Keep it in mind, it will not start with 0. Okay, it will start with -1, and it will be from back. So -1, then -2, then -3, -4, -5. That's how the thing is going to be printed. Okay, but this is what I said when my list was having a value like this, but I already did a reverse of this. So once I did the reverse, then the thing would be different. Okay, so as you can see over here, as I reverse it, so -1 is now going to be what? So this is what my thing is. So at 0 index I got 6, at 1 index I got at 1 index I got, at 0 index I got 9, at 1 index I got 6, and now when I'm going from -1, it will be from the reverse. So -1 is 1, so that got printed. When I'm going -2, the 2 got printed, so because it's a reverse order. Okay, and from here the -1, -2, -3, -4, in this way to moving on, right? I think it's making sense. Okay, now comes a thing where I can show you, if I have to get the data in a context, like I'm going for a slicing. I don't want to see all the data, I want to go for a specific data. So for that reason what we are doing is that we are using a slicing operator over here with the help of colon. So I'm saying that this is a starting bound and this is the ending bound, or I can say this is the upper bound, this is the lower bound. So I would be starting from 1. Keep it in mind, it's not 0, it's 1. So if my list is like this after reverse, this is what my list is. So 9 is at 0 position, 9 is at index number 0. So I'm not considering this because it has set to be 1. So for that reason it will start from 6. That means 1 to 4. Is 4 included? No, the 4 is not included. So it will be 1 to 3. So 1, that is this one, got printed. 6, then comes 2, got printed. Then comes 3, that is also got printed over here. I'm talking about this one. So this is 1, this is 2, this is 3, got printed. And 4 is not inclusive. Always keep it in mind, the upper bounds are not inclusive in context to slicing. If you're going with the slicing like this way, or whichever slicing you do, the upper bound is not actually inclusive. Okay. Now if you see over here, I did the slicing by incrementing 1 at a time. So it was like a jump of 1 place. What if I have to jump, suppose 2 place? Well, in that case you don't, and moreover I'm not saying that the starting bound, I'm not saying the ending bound. That's the reason there are 2 colons are there. That means it is going to consider the whole list. So when I'm not writing any numbers over here, and I'm not writing any n number over here, that means the entire list is going to be the part of this, right? So that's always keep it in mind. So if you're writing colon colon, it means that you're talking about the entire list, not the particular starting index or ending index. And I want to go for a step size of 2, that means the jump is going to be 2, right? So for that reason, let's keep it up in mind. This is index 0. And one more thing, when you start, like which position should you start from? Of course you start from index number 0. The index number 0 is inclusive, okay? That's the reason one, if you look over here, as you can see right over here, so yes, let's see this one, step size of 2, right? So indexing starts from 0. 0 is included, that's the reason 9 is included. 1 is not included, 2 is included, fine. 3 is not included, 4 is included. So 0 include, 1 not, 2 yes, 3 no, 4 yes, 5 no. That's the reason you got this list, okay? That's how it actually worked on. Keep it in mind when you're going for slicing with the step size mention, it will always start from 0 index, unless and until you are mentioning explicitly. In that case, you have to do it somewhat like this way. Then you have to put one more colon over here, and then you will be writing 2. Okay, in that case. So remember, when you're writing colon colon, it means that you are including a step size, and you are saying that this covers right from 0, index number 0 to n minus 1. Okay, that's really good. And now we have another beautiful function. So over here I'm discussing different list functions that are provided to us by default. Okay, and I go for the function called clear. When I did the clear, it cleared the entire list, and that's the reason when I printed it back, I am seeing an empty list, because there's nothing left after clearing the whole list. So all the data are simply been lost. So that was the part of my list which is of type homo. Now we'll go with the list with the type hetero. So here it is, and let me clear the screen so that you can see the output of this one. So let me write the program now. Python list underscore homo hetero, yes, and I will hit the enter. But before I do that, if you see, this time the list is heterogeneous. Previously you saw that I was working on 1 2 3 4, so that was like homogeneous, but this is going to be heterogeneous. Okay, so in this list what I'm doing is that I have got one integer, one string, one float, one boolean. A mixed community, right? Yes. So list will support heterogeneous data type. Keep it in the mind. The list supports heterogeneous data type, and that's the reason why you are seeing this particular piece of code. So if I print the data, of course I will be seeing all the value. Let me hit the data, and here it comes, all the values. So as you can see, it's 1, then Alice, then 3.14, and then boolean. And you see over here the list is represented within third bracket. So whenever you're talking about third bracket, it means I'm talking about the list. So list is represented right over here. Okay, that's making a sense, isn't it? So now I will go for append, and I already told you append means at the end. See, the value 5 got appended at the end, and I want to insert a new value at the index 2. Well, indexing starts from 0, so that means this is 0 and this is 1. That means after Alice, the Bob is going to be inserted, and that's what happened. As you can see right in this printf statement, after Alice the Bob was inserted. Always keep it in mind, the indexing would start from 0. That means list makes use of indexing, isn't it? I have been saying the word indexing so many number of times. I believe you understood that list makes use of indexing, and the indexing starts from 0 position. I want to remove Alice. Again, I'm telling you, I'm considering the data is there. What if the data is not there? That we'll handle in some other videos. So I remove that word Alice, and after removing the word Alice, if you print back, Alice is no more, right? Okay. In my previous program, I showed you about the implementation of sort function. Now can I perform sort? The answer is absolutely no. Why? Because I have got a heterogeneous list. So if you're having a heterogeneous list, how can you sort a number with that of a float, with that of a string, with that of a boolean? You can't. So if you fire the sort function on top of this particular list, my dear friend, you're going to get an error, because you have got string data over here. So sort function will work provided you have got a homogeneous list, not heterogeneous. Okay, but you can go for reverse. So I did that reverse over here. So after doing the reverse, as you can see, 5 came first, then true, then 3.5, and so on and so forth. So reverse is also working. Okay, now I'm going for indexing. As I said, that if you reverse the list, actually the reverse of the list has taken place. It was not just for show off, but actually it got reversed. So now at 0 position you have got 5. So when you're going for indexing, then they start from 0. So 0 as 5, and then to 1 I have got true. Fine. If I go for negative, then the indexing would be 1 for -1, and then the Bob for -2, like what you can see right for these two statements. And now I'm going for slicing. Again, it would start from 0, but I've gone for 1, so that means 0 is not included, true is included, then 3.4, and then Bob. 4 is not inclusive. Always remember, upper bound is not inclusive, it is exclusive. And now if I go for slicing with step size been mentioned, so it will again start with 0. So 0, 0, 5 is included, 1 is not included, 2 is included, 3 is not included, 4 is included. That's the reason you got this particular list. And finally you can go and give a call to the clear function. As I do that, list is now empty. Okay, I believe up to part 1 of day 1 is clear, right? And here I have written one point to remember. That also I want to show you that what are the key features that you will remember from this point. And here it comes. Let me make this thing a little bit wider. Yes, these are some important 5 key points which you have to remember in context to list. List is mutable. You can add list, you can modify list after creating a list. That's what we did. List maintain the insertion order, because the way you are inserting the data, at 0 index you inserted the data, at 1 index you insert another data, this indexing will be maintained. List is heterogeneous, so you can have integer, string, boolean, float, what not. Well, you can also have within the list another list. Within the list you can have a tuples, dictionaries, these things also. In the upcoming days I will make some task on these programs. Dynamic can grow or shrink the size dynamically, because as you're adding, the list is expanding, or as you're removing, the list is shrinking. So it has got the dynamic feature. And the most important thing, the list has got indexing. So you can go for slicing, you can go for removing, you can go for insertion. These are all happening with the help of index. I believe if you mention these 5 points about list, you are all good to go. Okay, so at the end of this particular video, we have completed day 1 up to part 1, but there is more to come up. Let me show you what is there in the part 2. Part 2 I'll be talking about tuples, and again the tuple has got homogeneous, heterogeneous. We'll expand and we'll go through all the programs. And the last of the part, day 1 is part 4, is iterator. So we'll even see the program that is there for iterator. So these things I will be covering in my next video. So stay tuned, take care, bye bye.